Okay, so let us continue with example 10. Alright, so here the manufacturer of a certain type of light bulb claims that the average lifetime of the firm's light bulb is 1000 hours. So if you look at the first sentence here, generally they didn't mention any word about sample. So we will assume that this is actually your population mean. Right? Then a consumer group thinks that the manufacturer is overstating the lifetime. So I think the keyword is overstating the lifetime of the light bulbs and test a random sample of 64 bulbs, recording the life X in hours in each bulb. Then the results are summarized. Okay, so from here, I think you can see very clearly that this is one of the keyword like overstating the lifetime. So that means now the lifetime shouldn't be 1000, it should be less than that. So the 1000 is overstating. Okay. All right. So no matter how, you can start with the part first. If you look at the question itself here, they didn't give you any information about the population variance. All right. They only give you the summarized value for the sample, but they didn't give you the population variance. So for this case, it might be the population variance unknown. Alright, okay, so no matter how, we can just start first. Calculate the sample mean. So for this part, it's very easy. I will just give you the final answer. Then you calculate this one yourself. So for the sample mean here, you should get 998.6. Okay, then for the second part, they ask you to calculate the unbiased estimates of standard deviation. Okay, for the lifetime of this light bulb. And then for part number 2 also, you calculate the unbiased estimate of standard deviation on your own. If you correct it to 3 significant figure, your answer should be 7.05. Okay, then after that, is there evidence at 10% level the manufacturer is overstating lifetime of light bulbs produced by the firm? Okay, so now you want to carry out the test already. So we can start writing out all the steps here. Okay, so just now in part number 2, you already calculate the unbiased estimated standard deviation. So which means this is case number 3. That means originally population variance is unknown. Yeah. Alright, so for part number 3, they want you to start the test. Okay, so you can start the test first. What is your null hypothesis? It should be mu equals to 1000 hours. I think I mentioned to you before, right? All the units are important here. And then for this one, the mu is overstating. Since the 1000 is overstating, means that we should expect less than 1000 hours. Okay, so this is your alternative hypothesis. And then usually I will write out a sentence about the alternative hypothesis. So for this one, I can say that the manufacturer is overstating the lifetime of the light bulb. Okay. All right. Then after that, so this is my first step. Okay, so I will want to continue with my second step here. So the second step is you need to list out the significance level. It is given, which is 10%, 0.10. And after that, I will always draw a diagram to help me. So I have a normal distribution graph, the normal graph, and then because this is a one-tailed test on the left, therefore my rejection region will be on the left-hand side. Okay, so this area itself is 0.1. The large area here is 0.9. So I want to get this critical value. So from the table itself, you look for the area 0.9. Okay, so when you look for the probability 0.9, the value of Z given should be, what is the value? 1.282. But because I know that on the left, right, it should be a negative value, therefore it is negative 1.282. So this is my second step here. Okay, then now I proceed to the third step. So for the third step, I need to calculate the test statistic. Okay, so for the statistic, it will be Z equals to sample mean. So your sample mean, you calculate just now, which is 998.6 minus the population mean 1000 divided by population standard deviation. So the population standard deviation is 7.05. But I write it out short here, but when I press calculator, I'm pressing the original long value. This value is cutting short already, right? So I'm actually keeping the long value for the standard deviation, and I will put it in the calculation when I press calculator. Okay, so I want to get the most accurate answer, therefore I keep it as long as possible. Then divided by square root 64. Then from here, you will see that if you didn't do any careless mistake, it should be a value of negative 1.588. This is your test statistic. Okay, so once you get the test statistic already, then you want to put it in the diagram to make a decision. So if you look at the diagram, negative 1.588, it should be from the graph, it should be before or in the area of negative 1.282, right? So this one is negative 1.588. So from the diagram, you can see that it is actually located in the rejection region. Okay, so from here, of course, you can make a decision, and also you can write out a conclusion here. So it is under the rejection region, therefore you can say that you reject the null hypothesis. And after that, you can write that's enough. Okay, so there's enough evidence to show that the manufacturer is overstating the lifetime. Is overstating the lifetime of the light bulb. Okay, so this is my complete test. All right, so you can see every step here. Step number 1, step number 2, number 3 for calculation, 4 and 5 for decision and also conclusion. Okay, so this is what we have for part number 3. Okay, then after that, we continue to part number 4. They ask you to state whether was necessary to use central limit theorem in your answer in part 3. So if it was, state what point it was necessary to use it. Okay, so this is some of the question that now they like to test students about whether you want to apply central limit theorem or not, all those things. Okay, so again, as what I mentioned to you before, you apply central limit theorem when they didn't mention whether your population is normal or not. So if you look at the question again, they actually didn't tell you the word normally distributed. So you are applying the central limit theorem in this case actually. Alright, so this is how we answer the question. Okay, so yes, you can write, yes, you apply the central limit theorem. Okay, the population distribution is unknown. So the population distribution is unknown. Okay, so when are you using the central limit theorem? So you can write central limit theorem is used, okay, to ensure that when sample size is large, okay, the sampling distribution is approximately normally distributed. Normally distributed when the distribution is unknown, when the population distribution is unknown. Okay, so this is how we answer the question now. Alright, so you should know when you actually apply the central limit theorem, when you didn't. Okay, so that's why you need to really analyze all the sentence in the question, okay, to see all the details here. Okay, alright, so example 10, this is what we have for example 10. Alright, so I will want you to continue with example 11 and 12, and I will just give you the final answer here. Okay, so if you have a look for example 11, okay, so there's a manufacturer claims that the average life for the electric light bulbs is 2000 hours, and then there's a sample of 64 bulbs tested, and the life in X hour recorded. So the result obtained as follows. So you have the summary, okay, for the sample value, and also they are asking at 2% level that the manufacturer is overestimating the length. So it will be very similar with what we have just now, like the example 10. Okay, assume that the distribution of the length of the light bulb is normal. Okay, so here they ask you to they assume that the population distribution is normal. So when you see this one, that means that you no need to apply CLT. No need to apply CLT. Different from example 10, right? Example 10, they actually didn't tell you whether the population is normal or not. So you apply central limit theorem in that case, example 10. So for example 11, because you see this sentence already tell you that the population is normally distributed, so you don't need to apply CLT here. But because they didn't give you any population variance information, so they only give you the summary of sample. Therefore, you need to do the unbiased estimated variance first before you can get the test statistic. Okay, all right. So I will give you only the answer, the short important answer here. Okay, so you can have a look at the summary for the answer for example 11 will be something like this. Okay, so you can see that the null hypothesis should be smaller than 2000. Okay, then of course I have to write out the null hypothesis on your own, and also the sentence and everything. I just summarize the answer in a simple way for you. Okay, then after that you should try to get the critical value. So you can get either negative 2.054 or negative 2.055 also been accepted. Then of course you need to draw the normal distribution graph okay, to help you. And after that, when you want to calculate the test statistics, you need to go through with the sample mean. Then this is the unbiased estimated variance. All right, so make sure that you get this unbiased estimated variance first. Then use all this value to get your test statistic, which is negative 1.93. If you didn't use the unbiased estimated variance, then your answer is negative 1.95, which is wrong. It should be negative 1.93. And then if you put all the test statistics into your graph and you try to do a decision, make a decision, so the decision should be do not reject the null hypothesis, then you write out a complete sentence for the conclusion. Okay, so this is a summary for the answer. Okay, so what we have for example 11, you have a try and then you double check with this answer here. Okay, so the same thing happened for example 12. So if you have a look for example 12 also, okay, so from a previous year's observation, the length of the salmon in the river is found to be normally distributed. So from here, you know that the population is normally distributed with the mean 65. So automatically, you should know that this is actually your sample mean. Okay, all right. So a researcher suspects that the pollution in water is restricting growth. So restricting growth, okay, is one of the keywords to help you to form the alternative hypothesis. Okay, so they've measured the length of X in a random sample of N salmon, calculate, and you get this one. Okay, where S is unbiased estimates of the population variance. So she then carries out an approximate hypothesis test. Okay, so these are the information given here lah. Okay, so first of all, she tell you that the test statistic has a value of negative 1.807, correct to 3 decimal places. They want you to calculate the value of n. Okay, so since they already tell you that the test statistic is negative 1.807, so what is the formula for test statistic here? Sample mean minus the population mean divided by the unbiased estimated standard deviation over square root n. And the value that you get is negative 1.807. So you try to substitute all the value that you have, which is sample mean 64.3 minus the population mean, which is 65, divided by the standard deviation, the unbiased estimated standard deviation. The value that it gives is 4.9 over square root n, and it is equals to negative 1.807. Okay, so continue from here. You will be able to get the n. So the n should be around 160. It should be in the whole number. So for this case, n should be around 160. Okay, so after that, they want you to, using this test statistic, carry out the hypothesis test at 5% level of significant figure and test whether the conclusion should be. State what is the conclusion. Alright, so again, you carry out the test on your own. I just give you the important steps here. So you should have your alternative hypothesis, which is mu smaller than 65 cm. So that's the first one, restricting growth. So that means it should be shorter, right? So the alternative should be mu smaller than. Okay, so the second, the critical value. Critical value that you get for this case should be negative 1.645. Okay, so test statistic is already given, right? So you no need to actually go and calculate again. So the test statistic is negative 1.807. Okay, so you put the test statistic in the normal graph and then you try to make a decision here. So the decision should be reject the null hypothesis. Then after that, you write out the conclusion sentence. Okay, so this is what we have for our example 12. Alright, so we ended the very first part of our hypothesis test. So you have learned how to, all the important terms, and then what is the method that you can use to carry out the test. We are using critical value approach and also the p-value approach. Alright, and then all the tests that we carry out in the previous example are about the population mean. Okay, and everything is normally distributed. So in the next video, we will proceed to the next part of the test. We are going to use binomial and Poisson to carry out the test. And we are going to test some other things else, not population mean anymore. Alright, so I will continue all this in the next video.